Yeah, hi Soma.
Hi, sir.
How are you?
Fine, sir. Thank you, sir. How are you, sir?
Yeah, I'm doing great. Okay, so just start with your introduction. So please describe yourself.
Okay, sir. Good evening, sir, and thank you for providing this opportunity to participate in interview. And myself, I am Sumlata, and I have completed my master's in VLSI from Indore Institute of Technology, and I have completed my BTech in Electronics and Communication Engineering from L&K Engineering College. And recently, I have completed my training in physical, and in that, I have learned what are the main inputs for PD, what is PD, power planning, floor planning, CTS, routing, and I have done three projects here. One is chip level, and other are block level projects. And coming to my hobbies, I read novels and watching movies, sir. Thank you, sir.
Okay, thank you Soma for wonderful introduction. So which movie? Okay, you in your hobby you say that you like to watch movies. So what kind of movie you see, like thriller movie or something action? What type?
Love stories, mostly love stories. I'll go, sir.
Okay, so which is your last movie?
Last movie, Samantha's movie, sir. I forgot the name.
Okay. So I
Yashoda.
think, yeah, so as you told, I think you have completed your internship from Siemens.
Yes, sir.
In which domain? In physical design.
Yes, sir.
Okay, and you also completed your MTech in VLSI design.
Yes, sir.
In which year?
2014, sir.
2014.
Yes, sir.
And BTech in which year?
2012, sir.
Okay. So after 2014, from 2014 to this 2002 or 23 means, are you in some companies or like you are preparing or?
Yes, sir. I worked in DRDO, sir. Some couple of years I worked in DRDO. After that, I shifted to Apollo Microsystems Limited, one of the electronic-based companies, sir. As a quality assurance engineer, I worked, sir.
Okay, that is some related to VLSI or
No, it's
something else.
completely quality related, sir. It's missile systems. It's
Okay, specific related to means like this DRD only.
yes, sir. Yes, sir.
Okay, is it your means like it is okay in PD? Okay, so if you completed your internship in PD, that means you know in and out of PD.
Yes, sir.
Okay, so okay, just explain me ASIC flow in a very means like not in the detailed way, in a very means crisp way at the upper level only. Explain ASIC flow starting to end. Okay.
Yes, sir. Sir, normally RTL, sir, RTL code, from RTL code to RTL. Generally, physical design, sir. Generally, physical design is nothing but it's convert circuit description to geometric description, sir. Whereas in ASIC flow, first is RTL code, next is RTL verification, and next stage is synthesis, sir. Next to floor planning, power planning, placement, CTS, routing, sir.
Okay, so this is basically you tell about means specific to the PD only. So actually, I want to ask like complete ASIC flow. Is it something start from like your architecture, your design idea, and these things? So that I want
Yes.
to yeah. So that I want to know from your side, like complete
Yes.
ASIC flow. Okay, that's okay. If you know that's okay.
Okay, circuit normally specifications will be there, sir. After that circuit description, and next stage will be RTL code, RTL to RTL verification. Next there will be synthesis will be there, and next physical design will come, sir, and physical verification will be there
Okay.
after manufacturing the chip, and next testing. After that chip will come out, sir.
Okay. Good. Okay, so tell me what are the inputs that is required for synthesis?
for synthesis, RTL, sir, .stc, and library, sir, and .lib file.
What actually synthesis is? Why do we need synthesis?
Sir, synthesis is a process of translation, mapping, and optimization, sir. It generally convert RTL. It convert RTL to gate level netlist, sir. First, in the translation, it convert RTL to generic netlist, sir. After that, it mapping to the technology. Then it will do optimization, sir. The whole process we call it as synthesis, sir.
Okay. So you say like there is an intermediate netlist that is a generic netlist. So what is the difference between like the generic netlist and the netlist that is generated after the mapping? Is there any difference or something like that? Same.
Sir, whereas generic netlist, it is not technology dependent, sir. Whereas in the after mapping, we get technology dependent netlist, sir.
Okay. That is synthesis. Okay. What is
it's not orientation will not be proper way in the generic netlist, whereas in the after mapping it will come in a
orientation means you are saying that orientation is not there, not means in generic. What does it mean actually? I'm not able to get it. Whatever you say that, okay, translational, mapping, optimization, the process of converting RTL code into the gate level netlist, is it okay? But you say that in generic, the orientation is not okay. So what does it mean? Which orientation?
So
Actually, orientation is not there in the generic netlist. Now, basically, it contains the logical connectivity. It doesn't contain any geometrical information. So
yes.
Okay,
yes,
no problem then. Okay, and okay. And what are the specification? As you said, it start ASIC flow start from the specification. So what means which specification or what kind of specification?
Any functional, sir. What if we are designing any block or anything, what it requires and what the outcome will be? It will be the specifications, the voltage or current, how much voltage it need, functional specifications, sir.
Okay, is there any like timing information, or apart from that there is some clock operating frequencies and number of IO pins, shape of the chip, size of the chip, power consumption?
Power consumption, power related information, voltage related information, size, block size, those things will come under comes under specifications, sir.
Okay. Do you know certain guidelines for the macros, for placing the macros in the core area?
Yes, sir.
Okay, sir, tell me.
Macros, their tracking macros should be placed side by side, sir, and the minimum spacing should be maintained, sir, between the macros. There will be and the macro should be placed to the core boundary set, sir, and the macro pins should be phased to core area, sir, and orientation should be as per R0 or R360, sir. It should not be R270 and R90, sir, and notches should be avoided, sir, and good floor planning is good floor planning should be there, sir, and orientation.
Okay, so do you know about like fly line analysis or something called hierarchy browser?
Yes, sir. Fly lines are nothing but the connection between the two macros. It will be displayed, sir. When using the fly lines, we can come to know that then two macros will be there. Wherever the connection will be there, we can identify, sir.
Fly line basically means the connectivity information. See, if you activate during your floor plan stage, if you activate the fly line analysis, So basically it indicates how your particular macro is communicate with the another macros or with the IO pins or with the different standard cells or whatever. Means how your macros communicate with the different component. That actually is the fly line analysis.
Yes, sir.
And what about the hierarchy browser?
Hierarchy browser is a top-down approach and bottom-down approach, sir. Means if one block, one chip is it's partitioning to another blocks, it will be bottom down approach, sir. Whereas top down, it will be participated, but subsystem wise it will be there, sir. It's I need to go through it, sir. Once I'll go through it, sir.
Okay. So just go through with like it is not just like that whatever you're saying for the hierarchy browser. So
Okay.
just you can see that hierarchy browser because it is one of the important guidelines before you place your macros inside your core area or whatever inside your die area.
Sure, sir.
Okay. Do you know what just after the synthesis there is something that we do before the floor planning? A certain steps.
Sanity
Just
check.
after, yeah, sanity checks. Okay, sanity checks. Or before the sanity checks, there is something because we sanity checks perform for certain. Yes, yes.
We import the design, sir, first. After importing the design, we'll do sanity check, sir.
Import design. Okay, you mean basically data preparation means loading all the inputs that are required for
Loading the library files.
Okay, so can you tell me what are the different inputs that is used that is used for physical design? Means what are the different inputs and not content? Just what are the different files that is used?
.lib, sir, .left file and .stc, sir, RTL and TLU file, sir, and technology file and RC file will be there, sir.
RC tech file. Okay, RC tech file. Yes.
And
who provides RC tech file?
RC tech file Foundry, sir. From Foundry we get.
Foundry. What is Foundry? And .left file?
Sir, .lib is a timing library, sir. It contains cell delay in terms of input transition and output load capacitance, and cell functionality will be there, sir, in .lib. PVT conditions will be there, and power information will be there, sir, in .lib. Whereas in left file, it is a physical information, sir. Physical information of standard cell, size and shape, number of pin size, shape, orientation, standard cell, all information will be there in the left file, sir.
Who provides you a .lib and .left file?
From IP vendor, sir.
From IP vendors, okay. IP vendors, okay. Do you know setup time and hold time?
Yes, sir. The minimum time is required to stable the inputs before clock edge occurrence is setup time, sir. And hold time is the minimum time is required to stable the inputs after clock edge occurrence is called hold time, sir.
Okay, before the clock edge, that is the setup, and after the clock edge, that is a hold.
Yes, sir.
Okay, that is a setup and hold. Okay. Okay, what is the difference between latches and flip-flop?
Sir, in latches and flip-flops are basic elements to storing the information, sir. It stores 1-bit information. In latches, it is having enable, sir. Whereas in flip-flop, it is having clock, sir. And both are sequential circuits, sir.
I am asking the difference, not the similarities.
Okay, sir.
Not too much, like the one main difference between the latches and the flip-flop. One or two.
Okay, sir, output in latches content will be changed based on if the input changes, the content will change, sir. Whereas in the flops, it won't change, sir. Whenever when rising and falling, it will change when rising and falling time only, sir. In flip flop.
Which is a level sensitive device, latches or flip flop?
Latches are level, sir, and flip flops are edge triggered, sir.
Okay, this is the main difference that I'm expecting from you. That like you can say that the fluff. Okay, all apart from that, you explain these things. That is after, but it's okay. No problem for that. So yes, latches is your level sensitive device, and flip flop are the edge sensitive device. Edge sensitive basically means your flip flop will active or the transition take place when either your clock is at the rising edge or the falling edge.
Falling edge, yes, sir.
Yeah, and that is basically, or in case of your latches, the latches will become active or the circuit will become active or the transition will take place during when your clock signal is either on a particular level, either on the high level or on the low level.
Okay, sir.
That's why during this level. So in generally for when I'm saying the D flip flop, so basically when I'm saying it the output follows the input. So not means only this during this period, only at the falling edge or the rising edge, the output follow the input.
Thank you, sir.
And okay. Just make the buffer from the XOR. Do you have a pen or paper?
Yes, sir.
Okay, show me. Just make a XOR. Just make a buffer with the help of XOR.
Buffer అంటే zero one a bar. Sir, 0 and B, sir. A bar B, generally XOR is nothing but A bar B plus AB.
Show me if you make the figure, just show me in the front of camera.
Sir.
Yes.
0 and B
First,
are input, sir.
Okay.
A bar B means A bar means 1 into B plus.
Wait. You just tell me only the input. For the XOR gate, your input is one is 0 and one is B.
Yes, sir. Buffer generally, whatever the input we are giving, we get the same output, sir. If we give A, we get A only, sir.
Means one of the one is A and 0. Okay. And if you want inverter, the same. So your input should be your 0 should be changed to, or it is same.
In inverter, if we give A, we get A bar, sir. Generally. So here one day. We need to 1, sir. 1 and B, sir.
Okay,
Input.
one or any one, either A or B. Okay,
yes,
and apart
sir.
from that, one is the input, then we get. Okay, that's okay. And how do you realize the multiplexer means NAND gate from a 2x1 multiplexer? Do you know?
Yes, sir. NAND, sir.
Yes.
0 B 0. Sir, selection line.
So first tell me how many inputs, how many output, and how many select line.
Sir, one selection line, sir, and
Okay.
two inputs, sir.
Okay.
Generally, multiplexer output I naught A into A bar I naught. For example, inputs I naught I1, sir, and selection line, if it will be A, then the output will be A bar I naught plus A I1, sir.
Okay.
Multiplexer output. So here, 0, I'm taking 0 B bar, sir.
What is the value of I naught?
0, sir.
0. Okay. And what is the value of I1?
B bar, sir.
B bar.
Yes, sir. A bar, A bar, B plus A B bar. Sir, sorry, sir. B 0, sir. Input I naught is B and I1 is 0, sir.
I1 is 0.
I naught is B, sir.
I naught is B.
Sir, I naught is B bar. Sir, I naught is B bar, sir. Sorry.
Just finalize and just tell me. Okay, and no problem. Just take your time and finalize and write in the chat. Write in the message.
Okay, sir.
Okay. What is the value of I net and what is the value of I naught and what is the value of I1?
Sir, I have sent message, sir.
I naught equals to B, I1 equals to 0. If you
B bar, sir. B bar, sir.
Okay, I naught equals to B bar.
So A bar I naught plus
That means your output should be for according to you A bar dot B bar.
yes, sir.
So A bar dot B bar is your NAND gate.
Generally, okay.
No problem.
AB
So
bar, sir.
when
AB bar.
yes, your NAND gate is na AB, the complete bar of AB. That means if you expand using the De Morgan's theorem, it comes to A bar plus B bar.
B bar, yes. Sir. Okay.
No problem. You can try it later.
Okay, sir. Okay.
Okay. Do you know? Do you study these things like network theory in your academics? Basics of network theory, KCL, KVL.
Sir,
Do you remember something?
no, sir.
Or no?
I have to go through it, sir.
Okay, no problem. Do you know about something parasitic extraction in VLSI?
Sir, parasitic extraction and resistor and capacitor values
Do you know?
based on the PVT conditions is
So
RC
my question is that why do we need SPEF? Do you know what is actually SPEF is? SPEF, DSPF?
Yes, sir. PEF contains resistance and capacitance values, sir.
So why do we generate? Is there any use of SPEF? Why do we generate SPEF? Oh, you perform something. You just suppose you generate the SPEF file, and definitely you use this SPEF file generate SPAF? How
Flo-
can?
Floor plan, sir. Sorry.
No, not floor plan. This thing again. Why you use? How can you use SPAF file at floor plan instead? Because the SPAF
minus 40, sir, and voltage will be 1.1.
No, I'm not. Okay, no, I'm not asking this thing. I am only saying that. Do you know about like for validating the setup time and the whole time we use the SPAF? So what is the use of the SPAF in the timing analysis? Like setup time, we have the different like worst. We have taken the some worst case scenario and the best case scenario or the worst delay. Worst delay basically means when the value of RC is maximum. So RC is maximum, and the best case delay when the RC is minimum. So that is basically when RC is maximum, this is slow corners, and when the RC is minimum, this is the fast corners. So that is why we have to use this for validating the setup and the whole time. Okay.
Okay, sir.
So for setup, generally it is not like that. Both the for this RC definitely created the delays or generate the delay inside your basically generate the certain delay that is associated with your design. But yeah, this delay, so that delay basically impact your timing critical one of the important file.
Okay,
Apart from that resistance and the capacitance, because it is your design, you know what you should know, like what are the resistance and the capacitance value that is associated with your design, because these are something called a parasitic that you don't create it intentionally, that is generated because of the internal property of the material.
Okay, sir.
Yeah, suppose you place the one metallic layer M1 and you place the suppose you place two metallic layers, the formation of capacitance. So how does the value of the capacitance and how does this value impact your timing factors or your setup and the whole time?
Okay, sir.
Okay.
Okay, sir. Thank you, sir.
Okay, so do you know about different stages of the routing? How
Early global route, sir. Two things will be there, sir. Early global route will do before routing only. It will we do, sir. After placement, we go for early global route, sir. 95% of the routing will be done, sir. To find out any congestion problems. So for that only we do early global route, sir. In the detailed routing, 100% routing will be done, sir. If any changes, if we need any floor plan will be changed, will be there in the detailed routing itself, we can find out, sir.
see like you are saying early routing. So generally in general what I am expecting that you say that like the routing you can divide the main three stages. Basically what is your global routing, that basically that is basically your routing trial, and second is called the track assignment, because track assignment, after that there is a detailed routing, that is a final routing. The physical connectivity between the different components depends upon the logical connectivity. Basically contain the physical connectivity of your design.
Yes, sir.
Routing is nothing but basically that is a physical connectivity different the different components on the basis of their logical connectivity. So basically you have to route the different modules with the different circuit with the help of different metallic layer. And apart from that there is before track assignment, because for a so you have a different suppose you have a different tracks and you have a different letter, you have a different metallic layer like M1, M2, M3. So M1 is associated with the which track, M2 is associated with the which track. So the tool first find this. And before that, there is something called the global route, that is the trial route.
Okay, sir.
So how does the tool calculate the, you said that you said that just 1 or 2 minutes ago, something called the congestion or these things. So how does the tool calculate congestion?
And sir, required available tracks versus required tracks, sir.
So how did the tool calculate the available tracks and this required tracks?
There is a command is there, sir. A report congestion overflow. So based on that, tool will do the how many required tracks will be there and available tracks are there. Based on that, it will calculate the congestion, sir.
Basically what happened after the placement stages, when you perform the first, there is something called the tool will divide the complete design into the small pixels or small cells that you call it the global route cells or the pixels. Then the tool will try to find the what are the number of available tracks. If your number of available tracks is less than the number of required tracks, then there is a congestion. But if your available track is greater than your required track, there is no congestion. What actually congestion? According to you, what is congestion? Just first tell me. What actually congestion is?
Sir, if available tracks are less than required tracks, then we call it as a congestion, sir.
What? Yeah, you call it as congestion, but what actually congestion is? That you are saying it is whatever you saying is a conclusion. See, if the number of available track is less than the number of required track, definitely then there is a conclusion. The tool report your design is congested. There is no routability. So what actually is a congestion?
The density of tracks will be more, sir, at a particular area.
The density. See, whatever you are saying, like pin density, cell density, in the basic, literal basic, in the layman. In the simple way, you can define the congestion is basically the obstruction in the route, the obstruction during your routing in the metallic layer. So if there is no available tracks, how can you route? How can you physically connect two different macros or two different standard cells and whatever, depending upon the connectivity? So that is the congestion. These are the reason of that. You can say that the pin density or the cell density. So how do you reduce the congestion? Suppose I am saying in your design, you find that there is a congestion. So how do you reduce the congestion?
Blockages, sir, by placing blockages or cell padding, sir. If cell density is more, we do cell padding, sir. Cell padding is nothing but we are allocating some space to the cells, sir, so that we can avoid congestion, and placing blockages, we can avoid the congestion, sir.
Placement during, okay, means you are saying that during the placement blockage, in the placement stage, we can places the blockages, that is a placement blockages, so that the tool will try to avoid this. Tool will try to avoid the standard cell or any component at this specific places.
Yes, sir.
Okay. So how do you optimize your setup time after the placement? Not manually, with the help of tools.
After design.
After placement, I am asking, how do you optimize your setup time? See, you see that if you after the placement you generate your timing report and you see that your setup is critical or setup is violated. So how do you optimize your setup time after the placement stage?
One command is there, sir. General after design and stage and setup, sir. By using that command, we can fix the setup, sir.
Okay, I agree that you are saying something like that. One of the ways that we can perform the placement, that is a timing driven. That means a timing driven placement means first the tool will try to place the standard cells in such a way to optimize the timing. So that is you call as the timing driven placement. Okay, what a second method, second way?
Timing placement. One is optimized placement, sir.
Yeah, that is you say that. Okay, that I agree that something you I say na that this is your something placement that is a timing driven. So the tool will try to place all the standard cell to optimize the timing, means it more emphasis on the timing. If you perform the placement by applying this switch timing, that is called something the timing driven placement. So what are the other way? If you don't know, then okay, no problem for that.
No, sir, I am not aware of it, sir. I'll go through it, sir.
Yeah. So you can go through with like magnet placement and all these things. Okay. Okay. Why do we use metal fills, dummy metal fills after the routing stage? Do you know? First, you tell me. Do you know what are metal fills or dummy metal fills?
Generally, in my design, I haven't used metal filter, but wherever if the metal density is more, metal there we use. I'm not aware of it, sir.
Okay, no problem then. No problem. Good, no problem. Okay. Do you know what is the use of filler cells? Why do we need filler cells? And at which stage we use filler cells? Just before the routing or after the routing?
No, sir. After routing, we use filler cells, sir.
Okay.
To fill the gap, we use, sir. Generally, only it's
So why?
only physical.
Why
only,
we need?
sir?
So why we need to fill the gaps, or to that you are saying, like, why do we fill the empty spaces after the routing stage or in the layout, whatever the empty spaces? Why we need to fill the empty spaces with the help of filler cells? Okay, that the name indicates, as the name is the filler cells. That
Yes.
definitely it is used to fill the empty spaces of these rows of the standard cells. But why? Do you know?
No, sir.
Okay, no problem. Okay.
There won't be any if we place physical cell, after that there won't be any cell won't come, any routing won't be happen in that place, sir, to avoid.
No problem. You can search. Okay.
Okay, sir.
Another question. Do you know timing equation for setup time and hold time, setup slack and hold slack?
Yes, sir. Setup slack is T minus T minimum, sir. T min is nothing but T clock queue delay plus T com plus T setup, sir. T minus T clock queue delay plus T com delay plus T setup is setup slack, sir. For hold slack.
No. Wait. I'm not asking. I'm just only I'm only just want to ask that whether you know or not.
Yes, sir. I know, sir.
Okay. You know. You know, like multi-cycle path, fall cycle path, timing exceptions.
Yes, sir. In false path, if any.
I'm not asking. I'm just only want to know that whether you know or not. Just tell me yes or no.
Yes, sir.
Okay. Do you know crosstalk analysis and signal integrity?
Yes, sir. Crosstalk, I know, sir.
What is crosstalk?
Sir, when two longer nets are there, one is aggressor net and one is victim net, sir. Due to the high switching, one signal will affected by another signal, sir. Due to the coupling capacitance, it will one signal will go to logic 1 to 0 and other signal will go to 0 to 1, sir. So noise will be generated, sir. This whole process we call it as crosstalk, sir.
So as you say that when the signal is flowing in the too long wire, so there should be, I think, a condition that basically when a too long wire that are placed with very minimum distance, that are very close to each other.
Yes, sir.
So that there is a chances. So if the current is flowing or if any signal is flowing in the two long nets in which the distance between the two net is very less, so there is a formation of the coupling capacitance.
Yes.
So there can be this. Yeah, so there is a formation of the coupling capacitance due to which it can impact the function. It can impact this kinds of even sometimes functionality. Even it can generate the noise. So we have the different cases.
Yes.
One net is the victim, one is the aggressor. So how do you minimize crosstalk?
Sir, length will be, we need to increase the length, sir, between the two nets, sir.
Length?
Between the space between the two nets, sir. We need to increase the space between two nets and we need to avoid the long nets, sir.
Do you know about something like that? Shielding, non-NDR rules?
shielding.
Non-default routing rules and NDR default routing rules and non-default.
Yes, minimum double width and double spacing are NDR rules, sir, to avoid crosstalk and IR drop. Sir, electromigration.
What is IR drop?
Sir, if any signal, if we give some particular voltage, the outcome won't be the same, whatever the input we have given, same we won't get, sir. There will be some drop will be there. That drop we call it as IR drop, sir. For example, sir.
IR drop is nothing. It is basically the voltage drop.
Yes.
At the voltage drop at the means basically what? Okay. You are saying some example, just say me, then after that I will explain you.
If we are giving 5 volts, sir,
okay.
In the end we get 4.7. There will be 0.3 volt drop will be there, no sir. That drop we call it as IR drop, sir.
So where will 0.3 volt goes?
Sir, I'm not aware of it.
So basically what happened between, suppose from the power supply there's a 5 volts.
Yes, sir.
And you are saying that your chip at the input pin or your VDD pin, your ICs or your chip gets 4.7 volt. So there will be a loss of 0.3 volt. So basically what happened in between the main power supply and the pin of your chip or the power pin of chip, there are lots of resistances like packaging resistances, ball resistances, and this kinds of resistance due to this nets or due to this wire or the conductor. So there will be a loss. So there will be a formation of like when I am saying IR is nothing but the product of the current and the resistance, and the product of the current and resistance is resultant, gives the resultant of voltages. So that is why. So in between the main power supply and your power pin or your VDD pin, so there are between lots of resistances, whether it is your packaging resistance, your resistance due to the nets or resistance due to some wire. So that is why some of your voltages drops. So how do you reduce IR drop?
IR drop.
Do you know something like decap cells or decoupling cells?
Decap cells act as this is also one of the physical only cells, sir, and decap cell act as a capacitor, sir. By using decap cell, we can avoid IR drop, sir.
How? Do you know? First, tell me. Do you know how, with the help of decap, how with by using the decap cell reduce these things? If you are saying that, if it is so. Yes or no? I want not an explanation. Yes. Only yes.
No, sir.
Okay. 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 Let me just wait. Do you know something called keep margin and hello?
No, sir.
Keep. Okay. No problem. Do you know CTS, clock tree synthesis?
Yes, sir.
Okay. Do you know clock tree synthesis? Do you know how does the tool build our trees? What is do you know only that? If you know, I want explanation. If you know, just ask me whether you know or no, whether you know or don't know. How does the tool build a tree? What are means like the concept of the sync pins, in pins. Then after that, there is an insertion of the leaf cells, that is a skew and
yes, yes.
Insertion of the leaf cell, that is basically nothing but your buffers or your inverters. Okay. If you know. Do you know antenna effect?
Yes, sir.
How do you reduce antenna? First, tell me what is antenna effect. What is the main cause of this, and and how do you reduce your antenna effect?
Yes, sir. During plasma etching process, sir, due to excessive accumulation of charges, gate oxide may get damaged, sir. So the whole effect we call it as antenna effect, sir.
Okay.
To avoid this, can I tell it, sir? To avoid this, we cut the metal and place another metal, sir.
You are saying some called metal hopping.
Yes, sir. Metal hopping, one of the techniques, sir.
So what is the difference between these two okay, you can. Do you know like why we go for the metal hopping, and what is the difference between, like, is the same metal layer or the different metal layer? Or just tell me the different ones. Okay, one is metal hopping,
Sir,
and I'm not asking you the question what is. You can just go after the interview.
there won't be accumulated charges in the if one metal layer is completely fabricated, there won't be any accumulated charges, sir, in that. So in the if we use the previous one, it will be get reduced, sir. There won't be any connection between the that metal to the another metal, sir.
Do you know about this antenna diodes?
Yes, sir. By by adding the by increasing the antenna diodes also, we can avoid antenna effects, sir.
So basically, usually when you add the antenna diode just before your, like, so basically what happens, your charge is accumulated over the gate terminal that can potentially your gate oxide is because there is a no discharge path
Yes,
of
sir.
this accumulated charge carrier. So by adding your antenna diode, you can, what happen, means you will provide some discharging path for the charge carrier that is accumulated over the over the gate that can potentially damage the gate oxide by trapping into it.
Yes,
So
sir.
there is a no discharging path. So basically, whatever you're doing, like by a metal hoop or like a antenna diode or this thing, you will provide a discharging path
Yes, sir.
so that the accumulated charge carrier discharge to the ground
Yes, sir.
without damaging your gate oxide or the
Gate.
thin layer of your gate oxide.
Yes, sir.
Okay. Okay. Do you know difference between wet oxidation and the dry oxidation?
No, sir.
Okay. Do you know the difference between the physical vapor deposition and the chemical vapor deposition?
No, sir. I'm not aware of it.
Okay, no problem. Do you know what is the difference between diffusion and ion implantation?
Ion implantation. Little bit time. No, sir. I
Okay,
need.
so what I'm saying, just after the lecture, just please go through the IC manufacturing process.
Okay, sir. Okay.
Okay. What is the threshold voltage? What do you mean by the threshold voltage of a MOSFET?
Sir, the minimum voltage required to invert the channel is threshold voltage, sir.
To invert the channel or to the formation? To invert the channel means you can. To invert the channel means
To invert the channel means invert the channel means to a scenario I'm aware of it, sir, but in terminology I'm not able to.
you can say that. Okay, no problem. So basically, threshold voltage is nothing but like in case of MOSFET, you apply certain gate to source voltages that is required to formation of your virtual channel, so that there will be a conduction path from the source to the drain, so the electron can flow easily.
Yes.
That is why you print a threshold. It is a threshold value. Okay. Do you know what are body bias effects or DIBL, trace induced barrier lowering?
No, sir.
Okay. Okay. So let me give you a one puzzle. Okay. Suppose you have a 9 ball.
Yes, sir.
Out of 9 balls, 8 have different weights. Sorry, 8 have same weights,
Okay, sir.
and 1 have different weight.
Okay, sir.
Do you already solve this puzzle?
No, sir.
Okay. So now I am giving you one weighing machine, and the condition is this: you can only use this weighing machine by 2 times. Only 2 times. Now tell me how you identify the ball which has different weight. I think from your expression, I am like you already counted this puzzle.
Similar question I have done, sir, but
Okay, no problem, no problem. Not just tell me. So if you solve a similar question, so you have only 3 minutes. Did you understand what is the question?
Yes, sir. Yes, sir. I understood, sir. Question I understood, sir.
Yeah.
In the first attempt, sir, if we if we place four and four in the weighing machine first, generally, and
Okay. If you place, okay. So out of 9 balls, you make a 2 chunks like 4, and 1 is remaining. Okay. And if you place 4 balls here, okay. Then
if the weight is same for the 4 and 4, in the remaining one ball, it will be the one, sir.
but okay, means the remaining ball is the remaining ball has different weight.
Different weight.
Okay, this is the one scenario. Okay, but what happen if
one scenario, sir, and in the other one, if the weights are not equal,
if the weight is not equal, that means your weighing machine show one of the different weight in the same ball from the same chunks. Like suppose you have suppose you have a one group a ball. Suppose you have a group A that contains 4 balls, and you have another group B that contains a 4 ball. If
yes,
the ninth remaining ball is means have the same weight, that means out of the group A and group B, your weighing machine show one of the group as a different weight.
Yes, sir.
Okay, so okay, suppose group, okay, I'm agree. Okay, group A, suppose the group A is more weight means the group A has higher weight. So how can you identify out of 4 balls which one is the ball which has a different weight, whether it is higher or whether it is lighter than the remaining balls or the heavier than the remaining balls? I'm only saying different one. So you can assume any of the conditions, whether it is heavier or whether it is lighter.
If sir, if for example, if we take if 4 balls having 1 kg, if the 4 balls, if one ball is if it may equal weight, or it may have higher or lower weight, sir. So I need time, sir, for this question. I need to think about it, sir.
How much time? 5 minutes, 10 minutes, or 30 minutes, 1 hour, 2 hours. Just tell me, no problem for that.
5 minutes, sir.
Okay, take it. Listen, I am giving you a hint.
Sir.
Just listen. And instead of dividing, see, you are dividing 2 chunks. One is 4, 4, 1. So you are dividing your 9 balls as a 4, 4, 1. I am giving you, instead of this, what happen if you're dividing your 4, 4, 1? Definitely you will able to get the one ball, different one, but you take it requires 3 chances.
Okay, sir.
The condition is that you can use the weighing machine only 2 times. So just now divide 9 balls with the group. Each group has 3 balls. Means you have group A that contains 3 ball, group B that contains 3 ball, and group C that contains 3 ball. That is total for the 9 balls. Means 3, 3, 3. Each group contains 3 balls. So now you have 3 groups. Now tell me how you proceed further.
త్రీ పెడతాము, 3 ఉంటాయి ఫస్ట్ దాంట్లో. 3, 3, 3. ఒక ఛాన్స్ లో ఇవి అక్కడ తీస్తాము. Sir, in the first chance, we took 2 balls, sir, and we place it both sides, sir. In the first chance, Three.
balls. Okay. It means you pick up 2 groups. Each group contains 3 balls. Means 3 means what? Just tell me.
3 in one side, 3 in one side, and
Okay.
3 aside, sir. First we
Okay.
pick 2 balls and place it in both sides, sir.
Okay, leave it. No problem. You can. No problem. Okay, so there's that's tax. Basically, this is nothing. This basically it is a this is a question that basically to check your basic aptitude. No problem for that. It is not related to technical, but yeah, it is for only the basic. No problem. But I want like approach. But okay, no problem. I'm not expecting the right answer or these things. If you give the right answer, that's very good. But you just tell me your approach, how you. But I am no problem. Just no. Okay, just leave it. Okay, the another question. And I hope that you will give the right answer because it is a technical question, not a aptitude question. Okay, so do you study analog electronics or do you cover analog electronics in your academics?
Yes, sir.
So, okay. So do you know like something called the MOSFET amplifier, current mirror circuits?
Sir, actually, the digital basics, I need to go through it, sir. In the long back, I have covered all these things.
Okay.
So now I am recollecting it, sir, actually.
Okay, or what about analog electronics? Is it okay for you if I am asking a question from analog electronics?
No, sir, I have to go through it, sir.
Okay, no problem. Okay, so you just tell me the name of any subject in which you are comfortable. That is related to your BTech. So during your BTech, you have majority 10 subjects that are on the, definitely in the BTech, we have a lots of subjects. But
Yes.
majority, there are around 10 to 12 subjects like control system, network theory, digital electronics, communication system, mathematics,
Yes, sir.
your electromagnetic field theory, electronic devices and circuits. Anyone or any one topic that is your favorite and you are comfortable with?
One topic. Topic అంటే ఇది చెప్తాము. Antenna wave propagation.
Okay, antenna. Okay.
Yes, sir. I like the subject, sir, actually.
Okay, antenna wave purpose. Okay, do you remember the equation of uniform plane wave?
No, sir.
Okay, no problem. Do you know something about this, the type of the materials on the basis of their permittivity, and how do you distinguish the conductor, insulator, and semiconductor? There is something, a factor that is the ratio of sigma upon epsilon naught, sigma upon W, that is the
I have
factor.
to go through it, sir. The terminologies, I'm aware of it, sir, but I need to go through it, sir.
Okay. Okay. Okay, no problem. Okay, so that's all from my sides. Any question from your sides?
No, sir. Thank you, sir. Sir, what are the, from my side, improvement areas? Can you tell me, sir, so that I can...
So, Soma, what I am saying that for technically, okay, you are good at something. But what I am saying, like, if your base is not good,
Okay,
then
sir.
there is no, if your base is not good or if your fundamentals are not strong, that there is no meaning of understanding all these things. If you know the physical design or RTL or whatever at very depth, but if you don't know like what is the like how does your flip-flop works, or definitely there is no link between it, but it is something like called the base. At every time you need this.
Okay,
So
sir.
what I am saying that whatever be the subject that is in your like BTech, like not all the subject, not the control system, not the electromagnetic field theory, not this, but yeah, I'm suggesting you to please complete all the basics of the network theory, digital electronics, analog electronics, CMOS inverter, and your electronic devices, like working of your MOSFET, working of your BJTs. Not if you're not covered with diodes, then no problem. Just only emphasis on your working of your MOSFETs. at every region with different conditions.
Okay,
This is a
sir.
fun feedback. First feedback. Second is that the second feedback is that for technical, like first I ask a question, I ask one question like asset flow, and you explaining me the PD flow. So basically, it is very important. If whenever you start some flow, because these are the standard questions.
Okay, sir.
So everyone expect from that you start from the design idea, then specification, then RTL design. See, because when you start from the RTL design, so from where? From where RTL design come? Na, the RTL design comes from the some specification on some design idea.
Yes, sir.
Because your RTL is nothing but it is your the textual representation of your circuit. How you represent your circuit with the help of a Verilog language or any one of the hardware description language. Okay, so that's it. Otherwise, overall, it is okay. Because I know I can understand that there is a long gap like after 6 to 7 years, so it is very difficult to sustain these things because technically is something that is never changes, but it can fade it away very rapidly within our mind.
Okay, sir.
So it is very very challenging to sustain all the technical concepts just for a long time, but no problem if you revise again and again, because you can cover, no problem.
Okay, sir. Sir, for I have this many years of gap. How the opportunity will be, sir? For me, it will be difficult, or can I get a chance?
Yeah, definitely. See, what I am saying that if you are good at something, then definitely you have 100% chance. See, so maybe sometimes, see, what you can do is just first complete all the basics, all the information about the PD, go through some hands-on experience on the tools if you are interested in the PD or whatever you're interested in the RTL design or whatever. Just first make yourself ready for the PD or for means going into the starting your career in this VLSI industries or whatever you want into this domain. Just first try to complete from your side.
Okay, sir.
Okay, then if you have any gap, so basically what happened, I'm not sure about, but yeah, I see lots of posts in through LinkedIn. So like majority of the company and some companies basically creates the opening only for those who have a lots of this career gap during your during your academics, or just because of your financial reason, or just because of your any personal issue. So I see lots of posts. So whenever you can find this kinds of posts that this kinds of opening that is basically for your those person or those individual who has lots of gap during your academics, then you can take this opportunity from there. You can apply there.
Okay, sir.
Okay.
Okay,
And
sir.
even no problem for that. First, what I'm saying that first from your side only, from your side, just complete everything.
Okay, sir.
Complete everything means all whatever the things that are required, the basics, the PD, everything. First, when you completed these things, then now you can. Meanwhile, you can do one thing also. Just start applying.
Okay, sir.
In all the companies, whenever there is an opening for freshers, see, whenever some post can apply, there is also some requirement. So we want a student from we want a candidate that is basically 2018 pass out, 20 pass out, 15 pass out, 16, 17, 18, 19, 20, 21 pass out. So this is the something that I cannot convey you right means this time, or I cannot assure you definitely you will get. So it is totally depend upon the conditions, requirement of the company. But yeah, for you, for you, it is a little bit challenging just because of this long gap.
Okay, sir.
But you can also treat it as in a positive way that you have an experience in some another company. So for you can treat it like that you are switching your job from one domain to another domain, or from one side to another side. So you can treat it as this is 5 to 6 year, whatever, from 2014 to 22. You can count it as in your experience if you have any experience. If you have, so that is the only how you can think, and how you feel that it is, whether it is a opportunity, you can treat it as your opportunity or it's a negativity. So no problem for that. But yeah, at the right time, this is not. I'm not the one that who can assure you that you will definitely get or you are not get. But yeah, one thing that I'm telling you, yeah, you can face a little bit challenging.
Okay, sir.
For you, it is a little bit challenging for as compared to the another candidates that are just passed out in the last year, or from that are from between the 19, 20 and 22 pass out candidates. So it is a little bit challenging for you. But no problem. if you prove yourself as a good candidate, or you can count it all the this 5 to 6 year as your experiences, then definitely maybe sometime it is beneficial for you, because you get a good CTC, because this experience is counted.
Okay, sir.
Okay.
Okay, sir.
Okay, then any other doubt?
No, sir. Thank you, sir.
Okay.